Large language models, or LLMs, have taken the world by storm. They can generate human-quality text, translate languages, and answer your questions in an informative way. But how do we know if an LLM is truly good? This is where evaluation comes in. Evaluating LLMs is crucial for several reasons. First, it helps us track progress in the field. By comparing the performance of different models on standardized benchmarks, we can see how far we've come and identify areas for future research. Second, evaluation is essential for choosing the right LLM for a particular task. Different tasks require different capabilities, and a model that excels in one area might perform poorly in another. Finally, and perhaps most importantly, evaluating LLMs is critical for ensuring their safety and reliability. LLMs are increasingly being used in real-world applications, where errors can have serious consequences. By rigorously testing these models before they are deployed, we can minimize the risk of harm. In essence, LLM evaluation is not just an academic exercise. It is a vital step in ensuring that these powerful technologies are used responsibly and for the benefit of humanity. Traditionally, LLMs have been evaluated using quantitative metrics like Perplexity and BLEU. Perplexity measures how well a language model predicts a sequence of words. A lower Perplexity score indicates better performance, as it suggests that the model is less surprised by the input text. BLEU, which stands for Bilingual Evaluation Understudy, is another common metric, primarily used for evaluating machine translation systems. BLEU compares the output of a machine translation system to a set of human-generated reference translations. The score reflects the degree of overlap in n-grams or sequences of words between the machine-generated and human translations. While Perplexity and BLEU have been widely used, they do have limitations. Perplexity, while useful for assessing a model's understanding of language structure, doesn't necessarily correlate with real-world performance on tasks like question answering or summarization. BLEU, on the other hand, is limited by its reliance on exact word matches. It fails to capture the semantic similarity between different phrases that convey the same meaning. Benchmark datasets have played a pivotal role in driving progress in LLM research. These datasets consist of a large number of examples, each with a corresponding input and desired output. By training and evaluating LLMs on these standardized datasets, researchers can objectively compare the performance of different models and track their progress over time. Some popular benchmark datasets include SQUAD, or the Stanford Question Answering Dataset, GLEU, which stands for General Language Understanding Evaluation, and SuperGLEU. SQUAD focuses on the task of question answering, where models are given a passage of text and a question about that passage. They must then identify the span of text within the passage that contains the answer. GLEU and SuperGLEU, on the other hand, are designed to evaluate a model's understanding of natural language across a wider range of tasks, including sentiment analysis, natural language inference, and question answering. These benchmark datasets have been instrumental in pushing the boundaries of LLM capabilities. However, it's important to note that even state-of-the-art models can struggle with certain types of questions or tasks. This highlights the need for ongoing research and the development of even more challenging benchmark datasets. Section 4. The Human Touch. Why subjective evaluation matters. While quantitative metrics and benchmark datasets are valuable tools, they cannot fully capture the nuances of human language and understanding. This is where human evaluation comes in. Human evaluation involves asking human judges to rate the quality of LLM outputs, typically on factors like fluency, coherence, relevance, and factual accuracy. This type of evaluation is essential for tasks that require subjective judgment, such as story writing, dialogue generation, and creative writing. While human evaluation is more time-consuming and expensive than automated metrics, it provides invaluable insights into the strengths and weaknesses of LLMs. It can reveal subtle issues with coherence, creativity, or factual accuracy that might not be captured by quantitative metrics alone. In addition, human feedback can be used to fine-tune LLMs and improve their performance over time. Section 5. Beyond the surface, evaluating context and reasoning. As LLMs become more sophisticated, it's increasingly important to evaluate their ability to handle context and reason about the world. Traditional metrics like Perplexity and BLEU are ill-suited for this purpose as they focus primarily on surface-level features of language. To address this gap, researchers are developing new evaluation techniques that specifically target context and reasoning abilities. One such approach is to create datasets that require models to perform multi-step reasoning or to track entities and relationships across multiple sentences. Another promising direction is to use adversarial examples, which are specifically designed to expose flaws in a model's reasoning abilities. Evaluating context and reasoning is crucial for ensuring that LLMs are not just fluent, but also understand the meaning behind the words they generate. This is essential for tasks like question answering, where models need to be able to comprehend the context of a question and draw inferences from the given information. Section 6. Stress testing. LLMs, ensuring robustness and reliability. Before LLMs can be safely deployed in real-world applications, it's crucial to ensure their robustness and reliability. This means testing how well they perform under pressure, when faced with unexpected inputs, or when operating in noisy or uncertain environments. Stress testing involves subjecting LLMs to a battery of challenging or adversarial inputs, such as nonsensical prompts, ambiguous questions, or inputs with spelling errors or grammatical mistakes. The goal is to identify potential weaknesses or vulnerabilities in the model's behavior. Robustness and reliability are particularly important for LLMs used in safety-critical applications, such as healthcare, finance, and transportation. In these domains, even small errors or inconsistencies can have serious consequences. By rigorously stress testing LLMs, we can identify potential failure modes and take steps to mitigate them, making these models more trustworthy and dependable.